Hello, welcome to WindLoad Solutions. In this video, we're going to take a look at ASCE 722 wind load calculator. So when you purchase the program, you will get a zip file. So the zip file, when you download it on your computer, then what you need to do is you can make a folder anywhere on your computer. You may have a file structure for existing projects that you have, but in any case, you just need to make a folder. And you just need to call it whatever you want to call it, wind load calculator for this case. All right. And then what we're going to do is we're going to double click on this to open the zip file. And then these are the files inside it. And you want to highlight them all. You can hit Control A for that. And then you can go over here and you can just dump them into the new folder, okay? Or if you have it open, you could drag and drop it that way too. But you just need to get them outside of the zip file, because if you try to operate the program inside, or any program for that matter, inside a zipped file, then you could have some trouble saving it. It's just trying to do everything inside the zip file instead of on your computer, which is something that the computer doesn't like to do. So once you get that done, then open all your files from there. Now, we're going to go through this, okay? So in these different files, we have read before using software, and there's also the disclaimer to look at. So let's take a look at this real quick. So number one, if there's a notification at the top of Excel that asks you to enable content, then you want to click that. Number two, if Excel prompts you to read only, open and read only, click no. And the reason for that is because we want to make edits, so we don't want it to be read only. Otherwise, you can't save it. Number three, cells in the program that have yellow colored cells, this is just identifying that this is a cell that needs an entry in order to function properly. Once you make the entry, then the yellow will go away. Number four, you'll find helpful information by hovering your cursor over descriptions, all of them that have a red tick mark at the top right corner. So those are the read before using software, and we'll take a look at that when we open it up. Let's take a look at these other folders. So we have velocity maps and table 1.15, and we'll take a look at that. So these kind of work together. So we're going to take a look at, here we have velocity maps. So here you see risk category 1, 2, 3, 4, right? Just zoom in on this. So we have risk category 1, 2, 3, 4. And then we have the maps, and they are risk category 1, 2, 3, 4. So based on whatever selection you have here, that's the map you're going to reference, okay? So let's take a look at the risk categories. So if it's your first time, we'll go through them. If not, you can fast forward through this. But first thing is, let's go through this backwards. So number 4 first. So number 4 is if you have structures, buildings, like a manufacturing plant, processing plant that has hazardous fuels, chemicals, or hazardous waste, anything that's highly toxic, then you're going to reference that map. And basically what you're going to get are higher requirements. So in the instance that a hurricane comes through, or a tornado, and your building, you just want to try not to have your building blowing apart where this hazardous waste is flying all over the place. So that's number 4. Number 3 is anything that's not in 4, but it could have anything that's like explosive substances. But basically what this means, just to boil down to it, is anything that has high risk to human life. So we don't want any fatalities. That's really what this comes down to. So if a building were to blow apart, we want to reduce the number of risks. So if you have a church, if you have a hospital, if you have a stadium, anything that holds a mass of a lot of people, then this is what you need to have category 3 for. Okay, so substantial risk to human life. We want to avoid that. So it's not toxic waste, but there's a lot of people in this case, and so if the building were to blow apart, the debris could injure a lot of people. Okay. Now, number 2 says it's everything except for 1, 3, and 4. Okay. So we know what 3 and 4 are. And number 1 is low risk to human life in the event of failure. What that means is, think of if you're out in the middle of nowhere. I like to think or explain it in the terms of a farm. So if there's a barn in the middle of nowhere, meaning that your neighbors are really far apart from you, okay? So it's just a lot of land. So the structure, if it were to be destroyed and debris were to fly, that the chances of that debris hitting a person is low, okay? So that's the way to think of it. So once you X'd all these out, the other ones, then what's left is 2. So 2 would be like a regular residential home, okay? So it could be a neighborhood. I know there's people maybe close by next door if it blows apart, but that's how you read this. So most cases it is a 2, but in these other cases, then you'll want to reference these other risk category velocity maps, okay? So what we're going to do for this case, we are going to do a home. And so I'm going to close this one out. I'm going to open up the risk category number 2 map, and we'll have it pulled over here. Okay, so we can take a look, and then I'm going to go back and just show you the other folder that we have. So this is wall and roof diagram. So if you don't have the ASCE book, then you can have these other folders for reference. Okay, so there's walls, and you can take a look at that one. We'll pull it over here. And so that's here, okay? And then we have for the roofs, we'll just take a look at one of them. They're all similar in the sense that they're referenced by the angle of degrees of the roof. So if you're 0 to 7 degrees, the pitch of your roof, then you'll use this one. If it's between 7 and 20 degrees, you'll use this one. 20 to 27, this one. 27 to 45 degree angle, this one, okay? So that's how to read that. Close that out, and then we're going to go now to the actual program. So let's get back into our folder, and it is WinLoad Calculator, and it's the Excel file here. So let's just double click on that. Okay, so again, we know we're going to do a structure. Here's the note that popped up. It wants to read only. We're going to hit no because we want to make edits, right? There's the yellow cells that we have to make entries. We didn't have a ribbon pop up. In some cases, it does pop up, so you want to enable content if that pops up. All right, so real quick, let's take a look at what's on this before we start making entries. So project information here on the far right. Client is Ernest Hemingway, and his address is 907 Whitehead Street, Key West, Florida. It's being done by WinLoad Solutions. We have a job number, and it's prepared by us as well. Okay, this does not need to be filled out, but it's good information as you do different versions of this for different structures that you have. Okay, and then determinations, this is colored. This does not need to be entered in. This is just determinations that are automatically calculated. Some things are defaulted here that you'll see, but it will adjust as needed based on the entries that are entered. Okay, so let's take a look. We could go look at our map, right? And we could say, okay, we're in Key West, Florida. And in Key West, we can say, let's look at our map. And we know that it's way down here, right? So it's in the 180 range. Now, these are contour lines, and it could be in between, whatnot. So if you really want to get the exact velocity, which you may want to, because as you adjust it, your pressures will adjust. So if you want to kind of dwindle it down a little bit, maybe you want to see if it's not 180, maybe it's a little less. And what we're doing here is the wind speed, right? So 180, according to the map, Um, but let's take a look at the first cell. What is this? And here are the red tick marks. So if you hover over it, then these pop up. So just hover over it. It'll tell you, it helps guide you through it, walk you through it as well. So design wind speed, what is that? We have nominal, and another choice is ultimate. So ultimate is really the one that you use the most, and that's what all of these maps are based on. The maps are all ultimate, all of them. So the only reason you choose nominal is if it's something that you know you can do. If you're familiar with it, you can contact your permit department, get their okay to do that, but that's going to reduce your pressures that you're going to get by 40%. Okay, so it's a substantial amount of reduction. So I don't recommend it. I always advise people that if you don't know, contact your permit department, ask them if that's something acceptable for your type of structure and location. Okay, so anyway, we're at 180, but we're like, maybe we can drop it down, maybe. So how would we know that? You could call your permit department. They probably would get frustrated that you're calling, but they could help you. The other thing you can do is you can go to your browser. This is available on the ASCE site, but we have it embedded in our website, so it's just easier to get to. And we call it the velocity finder. So if you go to windload.solutions, then you click on velocity finder, and it'll take you to the exact spot that you need instead of searching for it online and searching for it in the ASCE website, which you can get lost in a little bit. There's a lot of stuff in there. So here we go. We know this is where we got to go. It's called the ASCE 7 hazard tool. And if you have a smaller screen, just scroll down. It's shaded out. You just need to find this box and you need to exit out. Okay, then it lights up. Now, see this over on the top left? It says find an address. You want to enter your address here. So we know our address. It's right here. It's the Key West location, so I'm going to copy it. And then I'm going to just paste it in here. And then I'm going to hit search. And now let me blow this up for you. Okay, so it's like, oh, one of these you can pick. Say, yeah, okay. And then say search. Okay, now we can choose which ASCE version we're looking at as well. So we're doing the 22, so we're going to keep it on this. But let me pull it down, and you can do the 710, you can do the 716 as well. Okay, now the risk category. We just went through that not too long ago. We know it's going to be a residential home, so it's number 2. We're going to leave this soil condition as default, but you can get, more particular if you want. We're also going to leave this, but what we want is wind. You can look at ice, rain, tsunami, snow, flood, tornado, seismic, but we want to do this wind, and then after checking it, just hit view results, and that's it. And it says 176 miles an hour. So we know it's not 180, it's actually 176. Okay, so we're going to enter that one. Now, exposure category. I'm going to blow this up a little bit so it's better for the video. Exposure category. Okay, so again, if you hover over, you can see all the descriptions here. So I'm not going to go through that in this video, but B is the most popular, and if you're in the state of Florida, I think that's basically almost used throughout the entire state. Actually, I'll go through this real quick. So D is if you're on the coast. So basically, if you're a mile in from the coastline, then you're going to want a D. So this is something like a beach house that's right on the water, a hotel that's right on the water, or some resort, anything that's right on the water. You're going to want a D, okay? And then if you go in a little more, whoops, sorry about that. Typically applied if your structure is non-densely populated area, such as a farmhouse. Okay, so if you're more further in, but it's not densely populated, then you'll use a C. But in our case, it's there's a lot of homes, like residential neighborhood, like a city or town. Then that's a little more densely populated. That's when you use B. And then why is there no A? A was removed, I think, in the ASCE or after the ASCE 795. So A used to be a selection, but it's not been a selection for some time, maybe almost 20 years. So, all right, now we have the classification: enclosed, partially enclosed, open building. So enclosed is when you have, if let's think of just a simple home, okay? So 4 walls to a structure, and that's an enclosed home. Now remove one of those walls. Now it's partially enclosed because it's not a full envelope. You don't have it fully enclosed, okay? So that's considered partially enclosed. And then you have open buildings. An open building would be something where I like to think of like a picnic area. So you do have a roof, but you don't have any walls, right? So think of that as an open building. So in this case, we have walls enveloping the entire structure. So we're going to select closed. Okay. Now next is height above ground, which is Z. So what this is if you have a building or structure, let's talk about the beach house again. So if you have a beach house, usually they are elevated because this allows the water, high tide and whatnot, to wash through underneath the house without washing the house away. So it's set up on piles or whatnot. So in that case, the floor of that structure is raised. So that's the in feet, you want to put whatever that elevation is, okay? But in most cases, you're building the structure right off the ground. So in that case, you're at 0. So you can hit 0 or you can leave it blank. If you leave it blank, then it assumes 0. So you don't have to enter this in necessarily, okay? But if you want to see 0, then you can type it in. Now, then you have the building width and length. Now, I don't know the exact, I use the Hemingway house as an example. I'm not going to look up the plans. It's just an example, but I'm just going to type in 150 and 250, okay? And it takes the width and length, like which one's the length, which one's the width. The program actually does the analysis behind the scenes. So whichever case, in the scenario of like the way your roof may be located or rotated, like considering what's width and length, we do the worst case scenario. And the reason we can do this is because wind can come from every direction. So it's going to be the worst case scenario. Okay. Now we go to frequency information. So these are the standards that we leave. So we recommend just leaving them in. That's why they're actually entered in. So you don't have to deal with this. But we do have suggested range, but we also have some notes here. So if you want to do this little pop-up and you know that you have reinforced concrete, welded steel, then it's provided for you here. It'll actually let you know what you should type in. Okay, and period coefficient, again, you don't have to enter. I'd say leave it in, but if you know, then you can. You have the ability to actually enter it in and change it. Okay. Roof type, you're like, okay, well, in an instance, I'm just doing shutters. Why do I need to do the roof? Or I'm doing windows and doors for a house, and that's it. I'm not doing the roof. You still have to give the roof type. But it's very, general information. So you need to at least identify which type of roof it is. We do let you know that anything that's considered a flat, so flat, if you were with wind load calc with us in the way past, or previous revisions that we've had of the ASCE program, we did have a flat selection. But going through in the later versions, figured it would be better not to be real concise or associated directly with the ASCE, where they don't have flat listed. I think they did mention it actually in the past, but they don't now. So flat is considered gable. So if you do have a flat roof, then you'll select gable. Okay, so it's basically anything that's less than 7 degrees notated here. We're going to hit, for this example, we'll do gable with overhang. just to show this. Okay, so the height, the ridge height and the eave height. So this will be the tip of the roof. So let's just call it 50, and then the eave is the bottom, basically, without the overhang. We will enter 40, and then the roof overhang. So how much it hangs over the edge, and so you can enter whatever that is here. Okay, and then what if I go back and I'm like, no, actually it doesn't have an overhang? Then you will have to get rid of this. Okay, but if you don't, then it's not going to be accounted for. But please, try to be, you don't want to confuse the permit department if this is something that you're entering in, or anyone else in the company. So just be careful of what you enter in. But if you go back and you say, okay, it's just a gable, I don't have the overhang, then you can just say 0. You could also leave it blank as well. Now the parapet along the roof, so what is that? Some people ask. This is really like a wall on the roof. It's usually something that hides equipment that's there, so it's not an eyesore, but it's just a wall around on top of the roof, and you can put the whatever that height is in feet, and that will have an impact when the wind hits the structure. So if you don't have it, then just leave 0. Roof slope, it'll be between 0 and 12. So 12 by 12 is a 45-degree angle. Anything in between is from 45 degrees and down. Typically, this is on your architectural plans. If you don't know, and maybe you know the angle of the roof, take a look over here. So these are updating as we're making entries. And look at this one here, the roof angle, as we make an entry. We'll do, let's do 1. And that's, so that's 4.76 degrees. If we do 2, it jumps up to just under 10. 3, we're at 14. So if you know the angle of your roof, pretty much, then the angle is also automatically determined here. So you can check in that way as well. Okay, and then the mean roof height. This is typically, rule of thumb, is the midpoint between these two. Now you could get real technical and do it on CAD, or figure it out mathematically, but more or less what you're going to end up with is it's right in the middle for the most case. So, and then when you run all the calculations, it's just going to be minute difference. But however you want to do it, this is the mean roof height location that you make the entry. So in this case, we're going to put 45, which is between 40 and 50. Okay, and now this is all done. We have a rigid building. Here's our gust factor, topo, directionality factor, the edge strip of A, and roof angle, and our internal pressure. Okay. Now the topo, we say it's a flat, no hill, which means we're not on top of a hill. Now we can click this to see the diagram. So this diagram, based on which kind of situation you have, you have these variations, these values that you need to enter in from the bottom to the top of the hill if you're right at the top, or maybe you have a hill and comes back down, and maybe your structure is down here, right? So the wind would blow up, come down, and hit your structure, or in this case, it blows up and it hits your structure that's on the top. So if you have this kind of scenario, and it would have to be really that you're right at the top here, or you're right at the bottom of this hill here, that's when you would apply this. Otherwise, say you don't need that. Okay, but you would go and you take a look at these values, do those dimensions, and then you enter them here. Okay, and based on that, you would also need to say if it's a 2D escarpment, ridge or whatnot. But we're going to have flat in our case. And now we are done with this top portion, right? Okay, so now let's scroll down. And now we're ready to get our pressures. So this is for the wall information. So everything in the blue blue every other line is for walls. Let's keep going down. And then we have a roof section. So we had our gable roof, and so you'll do all your zones for your roofs here. Okay. So the top portion would be if you have windows, doors, shutters. Okay. Then that would all go here. And the description is good to have. So if you have architectural drawings and they're labeled, you may want to label it the same so you can just follow along. Otherwise, you can call it whatever you want, but it's a good idea to have an identifier. So you can just call it like window A, and then window B, and so on, or shutter 1 and shutter 2, right? Or door 1, garage door, things of this nature. It doesn't make an impact on the calculation, but it helps keep track of everything. Now we have our zones. So for walls, we just have a 4 or 5. So there is nothing other than that. And what a 4 is, let me explain first the 5. The 5 would be if it's on the edge. So what you want to do is you want to measure inward from the corner. So I'm just making this up, right? I don't even think there's a garage at Hemingway's house. But anyways, let's go to the value of A. So the value of A is 15 feet. And the value of A, let's go to our diagrams real quick, which are in our folders. Roof and wall diagram. There are the roofs. Let's look at the wall. So if this is your first time, take a look at this. If not, you can fast forward. See the value of A here. I'm going to zoom in. It's a little blurry because I'm zooming in so much, but it's right on the corner. So 5 are your corners, and they're measured by the value of A. So we already calculate the value of A for you, so you already know it. But you're going to measure it from this corner edge inward. And then everything left over on the inside is a 4. Okay, but if your shutter is right on the edge, and if it is inside this 5, you need to count it as a 5. It's not something that's just inside the 5. If it's even within it a bit, I would say an inch. If it's there, you should have the zone 5. Okay, but everything inside will do a 4. All right, so that's how you want to do that. So let's just minimize that. And then we have open and elevation. So we also have the note here. What you want to do is you want to measure to the center point of that window, shutter, door. Okay, so let's say window A is measured, and it's measured from the ground, right? From grade. So the ground to the center of A is in feet, and say it's 5 feet. Let's say B get my mic back on, had to get, let's just call this 10. Let's call shutter 15. Let's call this one 25. And let's call door 5 and 8. Just making these up for the example, okay? And then we have the width and the length of whatever the dimension is of each of these. And it's provided in inches. Now, why do we do feet and then switch to inches? Because your Anderson book or Pella book or whatever reference that you have, they are typically in inches, so it's just easier to reference and enter that in instead of have to convert it all the time. But it is Excel, right? So you could say, okay, it's 120 inches, but if you want that in feet, or you could say 10 times 12. You could do this, sorry, if it's in inches, whatever, you get the idea. I could say 120 divided by 10, 1 foot, right? Anyway, it's Excel. You can play around with it in this way, right? So in inches, we're going to say that this is it's a foot, and it's 120. So that's 120, okay? We'll call this 84. We're going to call this 100. We're going to call this 50. We're just going to enter these in. And you can see on the right how everything updates. We'll get the effective wind area of everything. and then we'll get the pressures as they adjust. Okay, and I'm just going to type in whatever just for the example. Okay. Okay, and that's it. You have all your pressures, and then say, oh, I messed up, and it's actually 150. Boom, done. And this one's 150. Okay, everything adjusts. So this is the main part, because these calculations, after doing all this easy stuff, is the hardest part, and then having to go through that tedious process is just wears on you after a while, especially if you have something due right away. Okay, next, NOAA information. You don't need to enter anything in here. It's not going to affect the program. We're done. We got all the pressures that we need on our walls for these windows, doors, shutters. Okay, but it's something good to have if your permit department requires it or your company wants to follow it. We put this in here because it was a request of users to have it, so more than delighted to add that in if it's helpful. So you have the NOAA approval number you can enter in here, the maximum pressure per the NOAA here. You can put your manufacturer's name and the model number of each of those, and it's just a good reference to have everything together. So again, good to have, but not required for your wind pressures. It's not going to impact anything. Okay. All right, so we are done with the wall part. Let's scroll down. If you don't need to do roofs, you can end the video. If you want to do roofs, stay tuned. We're going to go through this. Before we drop off on the wall section, though, let's just go down to these other tabs here at the bottom. So as we were making entries, we have these values that automatically are calculated and provided for you. So these are just some pretty standard variables, right? And if they apply, they're going to be populated. If not, they'll be left 0 or whatnot as shown here. Okay, so if we were to put dimensions for the topo, all these things would adjust. Okay, now adjustment factor, this is something that has been requested by permitting department before, so maybe not all, but it did happen, and so we just put it into the program so you have it. If your permit department asks for it, then we have the interpolation done for you, so everything's exact, but it tells you whichever exposure is in, and then so if it's C, right? So let's go back to the input. Let's just do it like a D, okay? And then we'll go back. So now D is filled out according to the requirements, and then you have everything. The mean roof height, right? So if we change mean roof height to something else, we're not going to get crazy and be out of our boundaries, but let's just put 47. It's between 40 and 50, and there's 47, and that changes, okay? And then the other one was the topo, so we just had a reference before, but those are the tabs. Okay, so you have everything there. So again, if you're done, you don't need to do any roof, then you're done with this video. But if you do need roofs, stay tuned. We're going to go do that right now. Now, what do we have here at the top? We had gable, so you can select whichever type of roof you want. Okay, and then based on that, you can go to your video, or I mean your folder. We can go into this folder, and we have roofs. We have a gable roof, so we're going to pick that folder. Our roof is well, we put a 4, but we're like, oh man, we need to know what degrees that is, know which one of these to use. Okay, well, it's 18.43, which is between 7 and 20. So this is the one we're going to use. Okay, so let's pull that up. We'll minimize that. And let me just blow this up. Okay, so you can see for the roofs, you have, again, I apologize if it's a little blurry if I blow it up too much, but you can see this is a top view of the roof, right? So this is the ridge, and then so what we have is 3, 3, 3, 3, and then the 2 is like the perimeter, so that's the side. So that's 2, 2, and on same on the other side, and then everything else is 1. And then you have, this is the actual chart, but this is what the program does for you. So you can use this for reference, but for the program to use this, you don't need this, actually. That might be Chinese to you anyway, but if you're not an engineer. But in any case, this is really what you need to look at. You need to know where your zones are at, because this is the value of A. So where you see these lines, so where there's this diced up, this is A. So 3, I like to go backwards, 3, 2, 1, because first you have, it's hard to see A because I'm blowing it up so much, but this is A, and this is A. So 3 is A by A, right? And then what's left over on the perimeter is A by that whole length minus this A, because that's 3, right? And then what's left over of everything else is a 1. Okay, so that's why it's easier to go backwards. And why, again, is that? Because we already have the value of A calculated for us through the program. So we know that everything for our roof here is A by A, or 15 by 15. So we're going to scroll down here. We're going to say, click the first cell, and we'd have a gable. Now, if it was a gable with overhang, we would select that one. But we have gable, and our zone is, we can scroll down, so based on whichever roof type you have, we have all the different zones to pick. And this is specific, so if you select something wrong and I put monoslope for a zone, it's not going to work. Okay, so we want to do gable zone 3. Now this opening elevation, this column is in the same file, so you do need an opening elevation for anything that's on the wall, but for roofs it doesn't apply. So that's why it's a NA, just to explain. Okay, come back down here. Does it stop on me? I think I scrolled too much. Stop. Stop. All right. I scrolled way too much with my mouse. All right. So 3 is 15 by 15. Boom, we're done already. Okay. Same thing with the NOAA over here, but we're already done. So this is effective wind area of zone 3. I'm going to zoom in a little bit because we don't need the NOAAs for the example. Positive, negative pressures. All right. And then we have a zone 2. And it's the same in our case for dimensions, right? Well, it depends on either side, but this is square. So 2 is the same here. There's 4 different locations, but you don't need to enter this 4 times. Also, there's 3, right? There's a 3 here on either side of the ridge on both sides of the structure. But it's the same. It's a worst case scenario because, again, wind can come from anywhere. So it could be here, it could be over there. So you just need to enter at 3. This is what it is for zone 3. This is what it is for 2. And then we have a zone 1. And we want to select 1 for zone 1 gable. Okay. So let's look at our roof. And if our roof doesn't have an overhang, and we are at 150 on the width. So 150 is 75. Right, which is half, minus the 15 should get us to 60, right? But we know it's 150, and if we want to look again, just to follow along, so 150 would be across here, then in half would be 75, minus 15 will leave us with this, by 15, which is A, right? So let's go back down. And it's Excel, so you can use that. You don't have to do it in your head. You can say, okay, for the width, I have 150. You could even do this. You could say equals, it's Excel. You could say equals this, right? Divided by, we're up here at the top in the formula bar, divided by 2. So that's the structure, and then minus, come over here, minus A, and pick it, and hit enter. 60, right? Length equals, scroll to the top, 250 divided by, let's see if I'm doing this. I want to make sure I'm doing this right. The length is, this is of the zone, so it's 15 equals A, right? Or equals 15. And that's it. And there's 4 times, it's the same. So we have 15 and then we have the other dimension, which is 60. All right, and then let's see. We have 1. Now 1 is, or actually we do have another 2. I was just thinking about that. So we do have to do 2 2s because there is the one along the ridge. So then we have the length one. So this is the width. Then we have the length. So the length is the whole thing, and we're saying that because we don't have an overhang. If you have an overhang, you need to consider it. Sorry, I didn't select it. I'm going to hit equals, and I'm doing it the long way just for the example. It's the length, so equals the length, and then it's not split in half because doing this whole length, it's not cut in half like this. But we do have 15 on either side because we have A and A for the 3. There's a 3, 2, 3, and we just want the one in the middle, right? So it's 250 minus A, and then minus here, minus A again. So enter. So it should be 250. Did something weird there. 50 minus 15 minus 15. Yeah, click something weird there. But that's what that is, right? And then, shoot, my bad. It doesn't matter. You could, what I was thinking, this is also the value of A. So it's the value of A, which is here, right? And then the length. But if you're going to get technical, this shouldn't change, but we'll do it anyway just to show. So this could be the width is 15 if you want to keep consistent with width and length. And then we'll do equals 250 minus 15 minus 15, or minus A. So see, it's the default worst case scenario. So you could flip them, but it was actually good that I did that just to show you that won't make a difference, so you can't mess up. The calculator we do already takes account for it. Last one is 1. Okay, so what's left over? We could actually just look at this, right, that we already did, because that's this interior portion and this one, right? So we already know what it is. It's going to be equals this, and the next one is equal to that, and that's it. So we did it. Gable 1, 2, both 2s, and 3, and we're done. All right. I hope that was easy to follow along. Now we could do every single roof type, but it's the same concept to just follow along. So if you need to follow the video, rewind and go back and forth, that's what the video is for. So best of luck with everything, and this should make life so much easier. Okay, and then this is also printable, so you can hit Control P, you can say print, and you'll have, just showed a snapshot. It showed, let me do it again real quick. Control P, and there it is, right? And then down here we can flip through. And when you print it, the header is left here at the top, so you don't lose that on each page. So you could look at the last page and you can still have all your information referenced at the top, okay? And then if you have trouble, in any case, a different printer, this is a PDF, so it should print fine, but you can always say print selection. So, and even if you just want to print a certain spot, so I just want to say I just want to look at, let's say I just want to look at this. Okay, so I say, okay, I just want to see this. I hit Control P or go to File Print, and then I say go to Print Selection, and it shows you, it still has the header, but it shows you just the section here. So you could do that if you want to, do pieces of it. All right, but that covers everything. If there's any other questions or you'd like to see something added, please let us know. We'll be happy to continue to do improvements to make everybody's life easier. All right, thank you very much.